Introduction to Mechanical Reduced Voltage Motor Starters. In this presentation, we're going to be looking at why do reduced voltage starters even exist? And then we're going to look at their stages of operation. The reason for reduced voltage starters existing is because of a graph such as this one. This graph shows a number of different torque curves for various rotor designs of skim three-phase motors. You'll notice along the bottom that they have an indication of the amount of torque developed when the motor is first started. Remember, that would be at a very low speed. Looks like the lowest of all of the motors is at about 150% of full load torque, and it goes upwards to approximately 275. Now, sometimes this level of torque at start can actually cause issues for the connected mechanical load, and due to this, we want to reduce it. So not all applications benefit from high starting torque from a full voltage start, also known as an across the line start. High inrush current is taxing on the power contacts as well as all of the electrical infrastructure. There is mechanical strain due to the forces applied to direct coupled equipment to the motor shaft. And finally, we also have at times drive belts that connect to the shaft of a motor, and if started too quickly with too much torque, we can get situations where there is significant slippage between the belt and the pulley. Systems like this do not necessarily need to be started at an extremely fast pace. Instead, it may be desirable to have a certain amount of run-up time for it to finally reach its full speed. Conveyor systems are among the most common applications of this type of industrial application, where we have a significant amount of conveyor, usually unloaded, when we first start, that needs to be brought up to speed. Even large fans like this one do not benefit from being started as fast as humanly possible. Instead, it's more advantageous to allow for a slow startup by reducing the torque available when first energized. The easiest way to reduce the starting torque is to reduce the starting voltage to the motor. A reduction in the starting voltage will then cause a reduction in the starting inrush current. And after the inrush current has been reduced, it will then cause a reduction in the starting torque. Now, there are two categories of reduced voltage starters: mechanical and electronic. For mechanical, we have typically four. There are others out in industry, but these are the four we look at. We have primary resistor, auto transformer, part winding, and star delta. All mechanical reduced voltage starters have a minimum of three stages to their operation. They have a starting position, a transition, and a running position. When we discuss transition, it means we're transitioning from the lower voltage to the full voltage. And there are two different types of transition. Open transition is when the motor is without voltage momentarily between start and run. Closed transition means the motor is never without voltage. Open transition starters are less complex when compared to closed transition, but the motor and the connected mechanical equipment can suffer from the abrupt forces that are exerted when full voltage is applied.